Hello, I'm Pravola Naidu. I'm going to be talking to you guys about generative AI and kind of how we use it within CSR and specifically my area, which is the Voice Compute Research Group, where we primarily focus on language technologies. Generative AI is fundamentally powered by language. So it's very much within our wheelhouse, and a lot of what we do is fundamentally within generative AI at this point. So how did we even get to generative AI, and why is it so big right now? For me, this started back when big data started becoming a thing. That's where most organizations and businesses started being more intentful about what data they're storing, how they're storing it, and how they're giving access to this data across their organization and between organizations. Once people started having data in a good state, they wanted to start analyzing it because that's what it enabled for them. It gave them a central store of their data to be able to now go wild with analysis. And from analysis, we started getting AI and ML being more interest in that because people were able to see that they could extract value from what data that they had. They want to be able to predict things, describe their data better, and prescribe things to business. So we kind of went through stages of people not understanding what they had or where it was in terms of their data to having a lot of data in their repositories, in their warehouses, in their data lakes, and wanting to extract a lot of value from it. A lot of the times, people had a lot of data that was in what basically not valuable to them because they were never intentful about how they were collecting their data. So you had a lot of data, but nothing you could really do with it. So over the last few years, a lot of what has changed is people becoming a lot more intentful about how and where they're storing their data and how they want to utilize it. A lot of forethought happening with what they're actually doing within their organizations, especially when it comes down to wanting to do predictive analytics and bringing AI into their organizations, which is still a very broad term in terms of what AI really means in an organization. It could be as simple as a regression algorithm for the most part, which would pretty much bring you as much value as a neural network in a lot of situations. And a lot of lessons that were learned along that way happily does not happen right now with generative AI in the sense that the way people are going about thinking about their solutions are different. They're not just going headfirst into, oh, cool new technology, let me just build a solution with it. People are doing that, but it's not as crazy as it was with machine learning. Because when machine learning started becoming a thing in industry and within businesses, people didn't really know what they were doing. There were a lot of attempts to do things, but not a lot of things were done very well because people didn't really know the protocols in terms of how do I actually evaluate these models? How do I actually make sure that when I put this in front of end users, it's not going to just break spectacularly because I don't know how my end users are going to use this. And when we come down to now generative AI, we have a lot of these problems solved in terms of the way of thinking, which is pretty much the biggest problem you have, where if you don't think about the problems correctly, you're going to have bad solutions. And a lot of the lessons learned when people were going through the big data and ML kind of hypes, they're applying to generative AI. So they're not necessarily going head first and not just going with crazy solutions, just investing lots of money into massive infrastructure to be able to host these things. They're taking a step-by-step approach. But even though that they're doing this, doesn't really absolve them of much issues. Because the issues with generative AI is not in how we host it and what data we give to it, but how we actually utilize it and where we utilize it. Because there's a lot of dangers in of itself with generative AI models when it comes especially to things like hallucinations and its accuracy and how factual it actually gives you a response. So how many people actually know what generative AI is here? Show of hands? Somewhat. I mean, it's pretty basic. Like, I generally have a lot of memes, and I wanted to put a cat picture, so cat picture. Um, there's a simple idea behind it. You give it some kind of prompt, and you create something new from it. What's in the middle is generally going to be a neural network that's attempting that. But it's not necessarily a new technology. It's just the scale at which it can be done, the level of capability that you can extract from these models now that make it so useful. We have always had generative AI. We've been using generative AI for model building for decades, but on much simpler basis, for much simpler capabilities, because we didn't really have the memory or the compute power to really go to scale. And one of the biggest enabling things for generative AI is the just general access to memory and general access to compute power to be able to just create large models. Because these technologies are not necessarily new. It's just the scale that has gone really wild. Like, this is a good example of how we're growing. And this is from a few months ago. Now there's a lot more models than this is. I think this is almost more than double in terms of the number of models you can probably find on the internet that are both open source and privately owned. GPT, I think, is about 6-7 years old, which is where we kind of started seeing how scale within these models can start bringing new capabilities, because that's when we first started seeing from simple prompts, being able to just generate large amounts of, at that point, nonsensical text, but still text that was grammatically correct, syntactically correct in terms of language, which was new to us. Wasn't something that we were really capable of doing much before without a lot of effort. This was now just a single model, put in a few prompts, give it something that you want, give it an idea, and it will just ramble on to you about it. From LLMs, one of the key things that are used now is RAG, which is Retrieval Augmented Generation. And at a baseline, it's just us adding a database into the ecosystem with an LLM such that it can actually retrieve information, then augment what it wants to give you, and then generate it. It's a way to try and circumvent the hallucinations and the general view that LLMs don't necessarily give you the most factual information, because the way it's trained, it's not necessarily memorizing anything. All it's doing is trying to predict the next word. Whether that word is correct or not, it's up to the model to decide. But all it's doing is just auto-completing the next word and so on. Because as it's generating, it's basically feeding a word that it's generated back into itself and producing the next word after that, and just continuing with that in a cycle. It's not necessarily creating an entire paragraph just immediately. It's producing it word by word. And because of that, you have a lot of unknowns with regards to, based on your training data, based on how it's being reinforced in terms of the data that is being used, will determine how and what that next best word is. So you don't really have control over what it's generating, because you have not controlled how it was trained. Unless you fully controlled and made a model from scratch for yourself, you're not going to really know and have a really good idea of what to expect from any given prompt for most of these models, because you don't know what it's been trained on. Most people don't really tell you the full extent of the data that they've used, because it's far too much to actually describe and give a good open view of it. So RAG helps us add our own data on top of that, utilize the capability of these LLMs that are able to generate text and generate good language, and then give it the right context to build upon that. Even with RAG, you still have issues of hallucinations, which is still a problem. It's not a completely solved problem, and it's not something that will go away anytime soon, because language is inherently ambiguous. Everyone uses language in a slightly different way. Everyone understands language in a slightly different way. That comes from based on your background, based on the languages you yourself know, based on how formal or informal you speak in a general sense. All of that complexity and randomness in terms of language changes how these models respond to what you ask it. Because I may ask the LLM in a certain way, you guys will definitely be asking questions in a different way because we all think differently as well. And fundamentally, language is just a way for us to communicate. The LLMs don't necessarily understand that context. It doesn't necessarily understand that the full context of what we're asking all of the time. When it comes to generalized aspects of life, maybe because a lot of the data is fairly generalized that we train these things on. But then when you start coming into more domain-specific environments, into your actual business, it doesn't really know all of the details. It knows how to generate language and the best words around certain terms, but it's not going to know how, or not going to really be able to determine what is actually factual and what is actually correct. Just what's the next best word? And there's another thing there that I want to talk about, which is graph rag. So there's different ways of storing your data. You could just chunk your data, chunk your text, and put it into a vector database where you use something like a similarity search to then check, okay, based on your prompt, what is the closest text that I have in this database, and then pull that information and then use it from there. You can have pretty good value from that, but you have to put in a lot of effort to make sure that the data that you're storing and how you're storing that data and extracting it into your database is valid. You can't just throw it in there and hope for the best because, well, you could in some cases, especially in low volume of data cases where you just maybe want to process a few articles that you're reading and you just want to summarize it for yourself. Sure, it will work. But if you want to start going into something more complex where you need to now get feedback about specifics within this data sets, where you're going beyond a singular domain, you have to be more intentful about how you extract that data and how you actually store it for RAG applications. It's still not something that you can just plug and play, though a lot of people do that. You get 80% there, and the last 20% is where you really have your issues. GraphRag allows us to put a lot more metadata and a lot more structure to how all of that is stored. That allows us a bit more surety in terms of the value that we're extracting from the data, and gives us a bit more ways of evaluating, is what the GraphRag doing valuable? Is it giving me the correct information? Is it collecting it correctly? But also enabling us to connect a lot more information together. When you're doing something like a similarity search, you're hoping that the right words are used in the prompt. When you do something like GraphRag, as long as it's something similar, you have all your different connections within your graph to tell you what are all the related topics. You're not hoping that something is related in your data set. You are creating that relationship, which gives you a bit more surety. Now, when you're actually getting into the real world, a lot of things change because the end users are the problem. It's not that they're actually a problem, it's just that because we're utilizing natural language, everyone speaks differently. You need to be able to make it such that no matter who's using it, it's going to give them a reliable response. You can't train your end users most of the time to prompt in a certain way. You need to allow the system to be able to work with anyone. And that's kind of the idea behind large language models. It's able to understand language in a general sense. But when you start going into domain-specific environments, you have a lot of terminologies that start clashing. You have people that know things in one area. For example, a lot of the times acronyms cause a lot of issues, where in a tech environment, there's a whole bunch of things that become acronyms within your day-to-day documents because you want to speed up your documentation. You want to make sure that you're getting ideas across faster and speed things up when you're generally communicating with your colleagues. But when you go between different departments, you often sometimes see the same acronyms meaning different things. How does the LLM know what the difference is? If you just ask it who the ANC is, or what ANC is. Depends on who you ask. If you ask the general population, they're probably going to say African National Congress. But if you ask someone that's maybe a sound engineer, they're probably going to say adaptive noise cancellation. They're not going to go to politics. They're going to keep within their worldview. So it does matter how you contextualize your data. Don't just throw things into it. You need to actually process it and add extra metadata such that you are giving these LLMs the best chance possible to understand what are you actually asking it, but also determine for itself, based on the data that you're giving it, whether this is the right match. Because most organizations don't want to just do it for one small team. They want to do it for their entire organization, which means a lot of different domains of data and information that needs to be put together. And you can't just throw this into one big pot and hope for the best. You need to actually be being a lot more intentful about how you're putting these things together and generally taking a step-by-step approach. Go for the big, most valuable aspects of your organization first that's going to be able to extract the most value for yourself, not just everything that you have. The other thing is how the data is stored. Because while big data was a big thing and people have a lot of good data and good storage, the data that we need to use for LLMs is not in that storage anymore. It's in SharePoint, OneDrive, your PCs, your emails. It's all the text that you've been working with, all the documents that you've been creating. And while some standard is done across some organizations for specific types of documents, it's not the same for all of your documents. Different departments, different areas are going to have their own formats, their own standards about how they create their documents. And for you to be able to now extract information appropriately from this means you now need to take a very custom approach for each type of document, for each format of document, for each area that you're working with, because there is no real standard across it. It's about how people are individually creating information to share with their colleagues. And those are your micro kind of areas that you need to identify and work with. And one of the more important things for us locally within South Africa is the localization of our technologies, where most documentation is in English, but that doesn't mean we shouldn't be able to have access to it in the rest of our 11 official languages. Most of the language models we use don't necessarily by default have capabilities for our language, for our local languages. A lot of what we do within the CSIR and specifically within our team is trying to make these technologies more accessible and more localized to our languages. So some of the things that we're actually doing, one of the first things that we started this year was working with healthcare data. We have access to a lot of healthcare data within the CSR and one of our research groups, Digital Health, where we're trying to create a more robust information retrieval system across all of those documents. Now, being able to just retrieve information is simple. Making sure that that information is factually correct and accurate for this is very important, especially within the healthcare and medical side of things, because you don't want to be giving someone the wrong response when asking a medically related question. So when we started doing some of this stuff, one of the key things that we needed to start doing was how do we evaluate these things better. Evaluation is generally overlooked because people will fine-tune a model or add a RAG system, ask it like maybe 5, 10 questions that they know the answer to, and be like, yeah, this works, and then move on with their lives. Not asking it the things that are more complex, that are actually ambiguous in their data set, because that's where your issues come in. But the reason why they don't do it is because they don't actually identify it from the get-go. You need to be more intentful about how you're curating your data and understanding what's in your data set. Most people have done data science on all of their organizational and operational data, but not necessarily on all of their documentation that they're storing. The other is us working with Discovery, where they want to build not necessarily a chatbot, but kind of a chat interface for their customer service agents, as well as for their end users. But they're taking a step-by-step approach. First, how do we help our customer service agents to be able to better help people? How do we get the information as fast as possible to our end users? And Discovery has a ton of different plans and just information about all the different things that they do. And it's not in a very consistent format. They have weird tables, they have weird formats in their documents and PDFs, which make it very difficult to actually extract useful information from it a lot of the time, because while it's very readable and quite useful or quite good if you're reading it with your own eyes, when you're trying to put this into a model or a system to start processing, it becomes a different problem, because it's no longer information just from left to right. It's blotches of information across your document. It's tables in weird formats that a model is not going to be able to just know how to process. You need to tell it how to process this, because it's a unique or new format. Another one is creating nonfiction content. Now, we kind of know that LLMs and these generative AI models can do fiction. They can create art, they can just create randomness for you. Just prompt it and it's going to do it well. But it does always have an issue of ensuring that it's always factual. RAG does help, but how do we then kind of do two parts to it? One is making sure that it's accurate, but also being able to just generate random content where it's not telling you the sun is blue kind of thing. You want it, if the sun is red, if the sun is yellow, tell it the sun is yellow. But how does it make sure that that's accurate? And making sure that that's consistent across a large volume of generation. Because you can keep consistency with maybe, well, depending on the context windows for these models, you can probably keep it around 2,000 tokens, 4,000 tokens, 16,000 tokens, depending on the size of your model. But once you start going beyond its context size, you're starting to lose actual context, and it's going to kind of forget what it's told you. So it could start veering off in different directions without your control. So building the right mechanisms and frameworks to actually utilize these is a lot of where we put our effort into, because we want to make sure that not only can we utilize these technologies, but make sure that we're giving people good information in return. A lot of what we do is kind of not done in isolation. We do it in collaboration with a lot of the different areas within NGEI, which is the cluster that I work within. NSA is primarily the impact area that I'm in. So we do a lot of things within gamified content and using this to build more content within our technologies, where we already work with a lot of text, but now how do we expand that to include a lot more variety in what it is with a lot less effort? Well, we're putting a lot of effort to build the models, but eventually it will save us some time. We're working with kind of e-government or e-health systems, operational intelligence, helping improve things internally in our teams. EDT for IR, that's more IoT related things, as well as NICIs, which is where our infrastructure comes from. Now, collaboration is important to us within the scope, because we can't figure out all the different ways that's needed for this technology to be utilized. We know how the technology works, we know how to implement it, but everyone's problems are unique. Everyone requires different things, and we need to create custom solutions generally for that. But we don't want to constantly be creating custom solutions. We want to be able to create something that's a bit more agnostic to what domain you're working within, what kind of content do you need to work with. The more examples, the more broadly we stretch ourselves in terms of what we're utilizing and how we're utilizing it, the better for us, the better we understand how we can help other people, because we can't think of everything on our own. Our main focus areas so far have been data processing, making sure that the documents that people have can be processed appropriately and put into these storage mechanisms correctly. as I said earlier, like people have a wide range of different formats and standards in terms of how their documents are stored. This is one of the biggest problems people have to even begin doing things like generative AI with LLMs. Our graph-based agentic RAG. So agentic RAG, I think yesterday some people talked about agents or kind of AI agents. Agentic RAG is kind of in that realm where you create essentially a swarm of RAG or LLM models that communicate with one another. You can have different hierarchies in how they work together, but you effectively create smaller workloads for your LLMs. Instead of giving it one big complex problem to solve, you break it down and let different LLMs solve those problems for you and then bring it back together. That allows you to actually solve a lot more problems because you're not hoping that the LLM is capturing everything that you need. A lot of the time, it overlooks things. I'm not sure if people have ever asked LLMs some really complex questions and it'll maybe answer 5 of them, but not all of them. Because it does have because it's not necessarily understanding what you're saying. It's just predicting the next word based on all of the words that you have given it. So it's not keeping track of everything appropriately. But if you start breaking the problem down and asking it to do that, you get a lot better results. And the last one is kind of creating domain agnostic solutions. How do we go from a domain specific solution and kind of generalize it for anyone to be able to utilize and for us to be able to take that knowledge and information forward to other solutions that we're building. A lot of what we try to do at the CSR as well as within our specific group, the Voice Compute Research Group, is trying to drive better awareness about how to utilize these models because it's not so much a problem anymore in terms of hosting. I think a lot of people have access to good infrastructure. It's more an issue about how do we actually go about thinking of utilizing it because people have access. People have these things at their fingertips. But how we utilize it and the safety around it, especially around the data that we utilize in these models, become important. We do share a lot of our work publicly as well as in conferences like this, so we try our best to make sure that we're not keeping our information siloed. We're sharing with as much and as many people as we can whenever they ask. And one of the last things I want to kind of talk about there is the R&D tax incentives that was released by DST earlier this year. It's something that we kind of try to make use of, where it enables us to work more with industry, where we since we primarily focus on things like research, allowing us to work with industry to do research as well, allows us to see a lot more real world problems, not just what problems we can kind of see within our research domain. The real world problems are where the real things are, where the smaller complexities start arising. And just lastly, kind of the CSR advantage in terms of working with us. We try our best to be multidisciplinary and be at the edge of research for 2 things. One is just context in terms of what is out there, how do we do things, because we can't be within a silo. If we do that, we're kind of closing ourselves up from a lot of information, a lot of context about how to actually make best use of our technologies. While we're oftentimes experts in the technology in of itself, when it comes to actually implementing that into the real world, we often fall short because we get so focused on how do we just use this technology, we don't often think about how the real world is trying to use it. So us being able to work with industry a lot helps make sure that we're thinking correctly, especially when we're designing our research, because we need to make sure that it's useful to not just us, but everyone else out there. Cool. Yeah, just partner with us. Any questions?